Welcome to the Chapter 4 Part 1 video. This video will be covering 4.1, 4.2, and 4.3. Before we dive in with the Chapter 4 notes, I want to go over how to mark diagrams because that will be very important for Chapter 4. Now, we've already been using these same markings, but I just want to go over it in a little bit more detail. So we're going to start by looking at the reflexive property. This will be used very frequently throughout Chapter 4. So what we're looking for the reflexive property is for one side shared by two triangles. So for example, here we have that WY is congruent to itself. So a segment or side shared by two triangles. Our statement could be YW is congruent to YW, or we could say YW is equal to YW. So this would mean that the sides are congruent. This means that their measurements are equal. And the reason will be the reflexive property. Our second diagram here shows vertical angles. Vertical angles are the ones that are formed by an X. So we mark those with the little congruent angle symbols. And what we're looking for are two angles formed by opposite rays. In other words, we're looking for a big X. And here we can say that angle ACB is congruent to angle DCE. There are other ways that we could name these angles. We could say BCA instead of ACB, for example. And then we can also write the measurement of angle ACB is equal to the measure of angle DCE. And the reason behind this will be vertical angles are congruent. Our next diagram here shows a midpoint. So it says D is the midpoint of AC. We know that a midpoint creates two congruent segments. So what we're looking for is a line, ray, or segment that bisects, which is intersects in the middle, a segment. Now we cannot assume midpoints. It has to be told to us that it's the midpoint or that it is a bisector. And so here we have that segment AD is congruent to segment DC, which means we can also say that the measure of segment AD is equal to the measure of segment DC. And the reasoning behind this will be the definition of midpoint. Right underneath that, we have segment bisector. And for a segment bisector, we're looking for the same thing. Here it's going to be a line, ray, or segment that intersects in specifically bisecting, so cutting it in half, another segment. I'm just going to put these little ditto marks. It means the same as above. And so on our diagram, we can mark that BD bisects AC. That means AC is the one that's being cut in half by BD. BD is the knife. Okay, so again, we have the same markings as above. AD is congruent to BC, and AD is equal to DC. And this will be the definition of segment bisector. And that is important to include the word segment because our next diagram is going to be for, instead of a segment bisector, an angle bisector. So this time we have a line, ray, or segment that intersects an angle at its vertex. So here we have WY bisects angle XWZ. And so we get two congruent angles here. We can say angle XWY is congruent to angle YWZ. Or we can say XWY, I'm sorry, the measure of angle XWY is equal to the measure of angle YWZ. So again, the angles are congruent, their measurements are equal. And this is by the definition of angle bisector. Okay, next we have the same thing, but it's bisecting a different angle. So just practice, make sure you're reading which angle this segment is bisecting. So the same definition, what we're looking for is the same thing, but this time we're looking at angle XYZ. And so we have different angles that are congruent. Here we have angle XYW congruent to angle WYZ, which means the measure of angle XYW is equal to the measure of angle WYZ. And this is the same definition of angle bisector. Our next diagram is for alternate interior angles. And here within my diagram, I'm going to mark the Z. And so we have AR parallel to PL. AR and PL are the top and bottom. There is my Z. And so which angles do we know that are alternate interior angles? That's this one and this one. Now you may be tempted to say, what about PRL? But notice that's not the entire angle that is created by the parallel line. Okay, so especially with polygons where we don't have just a straight line and a transversal, that Z is going to be extremely helpful. So what are we looking for here? We're looking for two parallel lines and a transversal. We want to make sure we use the Z. And what is our statement? We can say that angle ARP is congruent to angle RPL, or the measure of angle ARP is equal to the measure of angle RPL. And our reasoning will be alternate interior angle theorem. Okay, next we have another set of alternate interior angles, but this time our parallel lines are AP and RL, cut by the transversal between them. And so our angles formed by RZ are now these two. So we have the same reasoning, and we'll have the same looking for and the same reasoning. But this time our statement will be that angle APR is congruent to angle PRL, or the measure of angle APR is equal to the measure of angle PRL. And then our last diagram here, alternate interior angles, where we have AB parallel to DE. Again, here I'm going to use the Z method. So AB and DE are parallel, cut by a transversal here. I'll use a second color to indicate that we have a second transversal. We could also say that AB and DE are cut by this transversal. And so what we actually end up with are two pairs of congruent angles. We have the blue ones, and separately we have the orange ones. We're still looking for the same thing, but this here we have two Z's. And so we have that angle BAC is congruent to angle, the other blue one, DEC. Notice the vertex that's congruent is in the middle. So A and E, A and E. And this time I could have just said angle A is congruent to angle E because there's only one angle there. So we can also say the measure of angle A equals the measure of angle E. And we have angle B is congruent to angle D, or the measure of angle B equals the measure of angle D. And this is again by the alternate interior angle theorem. Okay, so these are going to be very helpful for when we're working on proofs, which we will be doing towards the end of the video today. So you might want to put this somewhere near the front of your binder that you can easily access it if you wanted to refer to it. All right, jumping in with the 4.1 notes, our objective is to recognize congruent figures and their corresponding parts. So we've seen corresponding angles, right? And that was angles that were in the same position relative to our points of intersection. Now we're going to be looking at congruent or corresponding parts of mostly triangles and quadrilaterals, four-sided figures and three-sided figures, okay? And what that means is that the parts are congruent to each other and they're in the same part of the triangle. That doesn't mean that they're facing the same direction anymore. Okay, so we'll see some examples. So the main thing we're looking at for this section is congruent figures. And that means shapes that have the exact same size of everything. So congruent polygons have congruent corresponding parts. They're matching sides and angles. When you name congruent polygons, you must list corresponding vertices in the same order. Okay, so what does that mean? Well, it means that if I have this congruent statement that triangle ABC is congruent to triangle DEF, that means the first angle, angle A, is congruent to the first angle, angle D. And the second angle, B, is congruent to the second angle, E. We can mark this on the diagrams as well. So A is congruent to D, B is congruent to E, which leaves C congruent to F. It also means that the segments between those same angles are congruent. So AB, my first two variables here, is congruent to the first two variables here, DF. AB is congruent to DE. DE. BC is congruent to then EF. BC congruent to EF. And so we say that these are the corresponding parts, the parts that are congruent. So these two segments are corresponding. These two angles are corresponding. So finally, CA, last first is congruent to FD. And so it's very important the order that we write our congruence statements. Let's look at this example here. So what we want to do is list the corresponding sides and angles of these two quadrilaterals, four-sided figures. So we have ACDB is congruent to QTRS. Let's start with the angles. Our first angle, A, has to be congruent to our first angle, which is Q. Angle C congruent to angle T. Angle D congruent to angle R. And angle B congruent to angle S. So we just kind of went down the line one angle at a time. And then we have the sides. So it sometimes is helpful to label it on here, A and Q, C and T, D and R, S, I'm going to put a little line, and B, because once you get to four little swoops, it becomes hard to count how many there are. So that's another way of marking congruent angles. Okay, so now we need the sides. AC, QT, right? The first two letters with the first two letters. AC, QT. Congruent statement, so they should be the segments. Make sure you're marking your segments. CD is congruent to TR. DB is congruent to RS. And then we wrap all the way around, so BA is congruent to SQ. And so we have 4 sides and 4 angles, and we have 8 congruence statements. Let's look at another example here. We want to find out if these triangles are congruent. In order for these triangles to be congruent, as of now, we have to list all 3 angles and all 3 sides. So we can start with angle A is congruent to angle E as marked. We have angle B is congruent to angle D as marked. And then we have our third angle, which we can say is congruent by a couple different ways. They are vertical angles, which are always congruent. We can also say, using the third angle or the triangle sum, that if we subtract these 2 angles from 180, it's going to be the same as if I subtract the same numbers from 180, right? So let's use vertical angles. Angle BCA is congruent to angle DCE by vertical angles. Okay, so we've got the 3 angles, we need the 3 sides. We have a congruence mark here that says AB is congruent to DE. We also know that if the measures are the same, then they're congruent. So we can say that BC is congruent to CD. And then we say here, these have the same measurement, so they must be congruent. That's AC and CE. And these are by definition of congruent. 3 sides and 3 angles, so yes, these triangles are indeed congruent. Let's keep going. On the next page, we have a scenario that we want to think about. Christine says that all 3 angles in these triangles could be congruent because they have 2 pairs of corresponding angles that are congruent, but Angela responds to Christine by saying this can only be determined if all 3 corresponding angles are congruent. Who is correct and why? Now, we briefly mentioned this in the last example. If I have 2 congruent angles in a triangle, then I can find the third angle for both triangles. To find the third angle, I can use the triangle sum theorem, which says that they have to all add up to 180. And therefore, Christine is correct because the missing angles must be congruent and measure 180 minus 55 minus 39, which if we put into the calculator, 180 minus 55 minus 39 is 86 degrees. And therefore we can see that these triangles have all 3 congruent angles. Now that does not mean the triangles are congruent. It just means the angles are congruent. And so we have this theorem, the third angles theorem, which says that if 2 of the angles are congruent, then the third angle must also be congruent. This is important. It will come up again a few times throughout this notes. So let's look at an example. Congruent triangles. So we want to mark up the given information and then determine if the angles are congruent, just the angles. So we have angle A is congruent to angle D. A and D are congruent, which means this is 40 degrees. And we know the measure of angle F is 80 degrees. Well, in order to know if all 3 angles are congruent, I need to know the third angle. 60 and 80 are not the same measure, so we need to find this third angle. 180 minus 80 minus 40 equals 60. And so we know this angle is 60 degrees. 40 and 60 match, then 80 must be the same because they both have to add up to 180. So then this must be 80 degrees, and yes, all the angles match. Okay, in our part B, we have EV is parallel to LO. Anytime I see that parallel lines, I'm going to draw the Z. EV is parallel to LO. And then we have that angle ELV, L is in the middle, is congruent to OVL, OVL. okay? But we also know, because of the z, that angle EVL is congruent to angle VLO. So we can say angle EVL is congruent to angle VLO by alternate interior angle theorem. And if I have two congruent angles, then angle E must be congruent to angle O by third angles theorem. Okay. Our next example, we want to prove that the triangles are congruent, and we're going to do this by writing a proof. Okay, so we have a given, and we need to prove, so we need our two columns, statements and reasons. Make sure when you're doing your two columns, you actually write statements and reasons at the top. We're going to start out with what was given to us. LM is congruent to LO. MN is congruent to ON. Angle M congruent to angle O. Angle MLN is congruent to angle OLN. And then I'm going to go through and make sure all of this is marked. So LM and LO, MN, ON, angle M and O, MLN, OLN. Okay, so my diagram matches my given statements. For our next step, we have to know, what do we need in order to prove these triangles are congruent? Well, I need 3 angles and 3 sides. I have 2 angles. How do I get the third angle? Well, we know that the third angle, angle MNL, must be congruent to angle ONL by the third angles theorem. And so now I've got 3 angles. I need 3 sides. I've got 2 sides. I need the third side. How can we get that third side? Well, it's the same segment, so we can use the reflexive property. Ln is congruent to Ln by the reflexive property. And now we have 3 angles and 3 sides, so we can finally say that the triangles LMN and triangle LON are congruent by definition of congruent triangles. Now I have good news for you. We won't have to find all 6 pieces of information for very long. But for now, that's still what we need to do. Let's take a look at the next example. For example 3, this is not a proof, so we don't have to write out our statements and reasons. All we're looking for is the value of x and y. So we're going to use everything that's given to mark up our diagrams. We have DEFG. DEFG is congruent to PQRS, which means that all 4 sides and all 4 angles make congruent pairs. So we have PS is 24. GD is 5y minus x. Notice PS and GD are congruent pairs. Those are congruent sides. Angle D is 100. Angle P is 7x minus 12 degrees. Well, if we look here, angle D and angle P are congruent because they're both listed first. So those are also congruent. So what do we want to start with? Well, this uses x and y. We need an equation that uses just one variable, so let's start with the angles. We have 100 equals 7x minus 12 plus 12 to both sides. 112 equals 7x. Divide by 7. 16 equals x. And now we can use that to find y by setting our congruent sides equal to each other. And so we have 24 equals 5y minus x. Substitute in our value of x, which is 16. Add 16 to both sides. So now we have 40 equals 5y. Divide both sides by 5. 8 equals y. Okay. Our last example for this section, we have a diagram with triangle LES, which is congruent to GES. That means that angle L and G are corresponding. Angle E corresponds with itself, the two angle E's, and angle S with angle S. So let's look. We have LE is 10y minus 30. GE is 4y minus 18. Those are corresponding sides because LE and GE are in the same place in our in our congruency statement. LS is 13. Angle SEG is 7x plus 8 degrees. Angle LES, which is congruent to the other given angle, is x plus 20 degrees. Okay, so we have two congruent angles and we have these two congruent sides. Let's find x first. X is with our angles. So we have 7x plus 8 equals x plus 20. I'm copying it from the given just to make sure I didn't make any copy errors when I copied it onto my diagram. Minus x, that gives me 6x minus 8 gives me 12. Divide both sides by 6, x equals 2. For the value of y, I want to set these two congruent sides equal to each other. And so we have 10y minus 30 equals 4y minus 18 minus 4y plus 30. 6y equals 12. Divide by 6, y equals 2. Okay, so we'd like to continue using these congruences, but we don't want to necessarily find all 6 pieces every time. And so on the next page, we'll be able to kind of cut down the amount of work we have to do. So let's take a look at 4.2. Our objective now is to prove that two triangles are congruent by using SSS, SAS, ASA, and AAS. And that will make sense in a few minutes. Okay, so in the past, what we just did, we had to have 3 angles and 3 sides. So 3 congruent angles and 3 congruent sides. And we can list them here. We had angle A with angle D with one congruence mark, angle B with angle E, angle C with angle F. And then again, I'll just start with a single congruence mark. We have AC with DF. 2 congruence marks is AB with DE. And 3 would be BC with EF. Whew, that's a lot. So let's see if we can cut it down. Our first postulate is the side-side-side postulate, which is SSS. And that states that if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles are congruent. The way I remember this is if you think about having 3 sticks and you arrange them into a triangle, there's only one triangle that you can make. And therefore, if the 3 sticks are all the same length, the 2 triangles must be the same. Okay? If we're looking at these triangles, the angle that's between 2 sides is called the included angle. And you can have an included side, which is the side between 2 angles. So if we look at our diagram here, and we look at GH and GF, the angle between those is angle G. So angle G is included in side GH and side GF. If we look at HF and GF, The angle that's included between those is angle F. Okay. And for sides, we do the same thing. We look at here is angle H and angle F, and between those two angles is side HF. And the reason that's so important is for our next postulate, which is called the side angle side postulate, or SAS. And that states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So if the angle and the sides that are touching it are congruent, then we have a congruent triangle. Okay, let's look at a couple of examples. We'd like to determine if each pair of triangles below is congruent by SSS or SAS. If there is not enough information, just say so. And we're going to explain. I have the first couple formatted. So we have TP congruent to GD, TP, GD. Those are corresponding sides. And now we have PE congruent to DO, PE, DO. Different number of congruence marks because PE is not necessarily congruent to TP. And we have angle P congruent to angle D. So I want to make sure this is the one included in between those sides, included between those sides, and therefore these triangles are congruent by SAS, side angle side, SAS. So now we need to know, how do we write the congruence? Well, which angle is congruent to angle P? That's angle D. Which is congruent to angle E? Well, from P to E, we passed through the side that had two congruence marks. So we start at D, through two congruence marks is DO, and then our last one is G. So I'm using my congruence marks in order to find which angles go with which angles. Part B, FE is congruent to HG. GF is congruent to EH. FH is congruent to HF. We could also say this by reflexive property. And so we want to know, do we have a congruence here? Yes, we have three sides, so this will be SSS. Which, since we have sides, I'll say which side goes with HG. HG goes with EF or FE, but which way do I put it? Well, I started from my three marked side towards my two marked side, and so I'll do the same thing. Here's my three hash marks and my two hash marks, and so I say this is FEH. Okay, if you write this as EFH, it is incorrect. It is very important to have those in the correct order. Let's look at C. Now this one doesn't have the vertices marked, so we'll just be stating if it's a congruence or not. So here we have side, 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 yes, by side, side, side. Okay, here we have side angle, whoops, right? Side angle, it should be this side right here with the two congruence marks, but it's this one over here. And therefore, we do not have enough information. Not enough information. Notice this would be SAS, but this is SSA. Not the same thing. So let's learn another postulate. I'm going to mark here, SSA does not work. Our next postulate is ASA, angle, side, angle. And it states that if two angles in the included side are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So we have angle, side, angle. And we always read it in the order that they're touching each other. So if I started with this angle, it'd still be angle, side, angle. Okay, so let's look at a couple of examples here. We want to mark the diagram with the given information and then determine if the triangles are congruent. So we have angle B and angle R, angle A and angle Q, side AB, side QR. Angle, side, angle. So how do we name our parts? We have A with Q, 2 congruency marks, B with R, 2 congruency marks, and that leaves C with S. In our next example, we have AB congruent to QR, AC congruent to QS, and angle B congruent to angle R. Well, here we have SAS, which would work, but this would be SA. It should be this side that's congruent, and it's not, and therefore we do not have enough information. Again, we have that side angle that does not work. Notice I write it in a very careful order. Okay, let's look at a next example. For example 3, we're finding any additional congruent parts that we need in order to prove that the triangles are congruent. So we have TH congruent to CH. We have MH congruent to DH, which means that we have 2 congruent parts given. We need 3, which means we need 1 more. Right? All of our new postulates all have 3 congruent parts or pieces that we need. So what do we need? Well, we have 2 sides. We either need a third side or an angle. And if it's an angle, it has to be the angle between the 2 sides. And so we can say, oh, look, these included angles are vertical angles. And so we have angle THM congruent to angle DHC by vertical angles. So we have now side, angle, side, and that is what we can use to say that these triangles are congruent. So which angle is congruent to angle M? M is next to the side with 2 marks, D is next to the side with 2 marks. T next to the side with 1 mark, gives me C, and H is the congruent, the 1 congruent mark. And our next one, T is the midpoint of RP. That doesn't tell me immediately a congruence, but we know we can use the definition to get a congruence. ST is congruent to QT. SR is congruent to QP. So we're given 2 congruences. We need 1 more. And the 1 more that we need comes from midpoint. So we can say RT is congruent to TP by definition of midpoint. And so now we have 3 congruent sides. We have RTS. So RTS goes from 2 congruence marks towards 1 congruence mark. So we're from 2 towards 1 tells me this is going to be P, T, Q. In the next example, we want to decide whether the triangles are congruent. If they are congruent, we're going to mark the diagram and write the congruent statement. Well, I find it easiest to mark the diagram as we go. So angle QPR is congruent to SPR. Angle QRP is congruent to SRB. So we have two angles, we need a side. Okay, we always need at least one side for these congruences. And luckily we can say that by PR congruent to itself, which is reflexive property, we can get angle, side, angle. So which angle is congruent to P? 1 mark, 1 mark. Q goes with S, R with R. And number 2, we have HK and JL, HJ and KL. Well, we need either an angle or a side. And here we have KJ is congruent to itself by reflexive. I did say it was going to be important. So now we have SSS. Which side goes with H? Well, H is between 1 and 2. L is between 1 and 2. K is between 1 and 3. J is between 1 and 3. And then our last one, we have L, J, K. On our next example, we have DG congruent to DF, angle G congruent to angle F. We need another angle or another side. If it's the other side, it has to be the ones that are against the angle. If it's the angle, it has to be the ones around the side. Well, we don't have either of those. I have nothing that tells me that, that the only thing I have is that this side is congruent to itself, right? That would be the reflexive property, DE and DE. But that's not what I need. I need these angles or I need these sides. And so this has not enough information. Here we have angle E and R are right angles. Let's move the paper. E and R are right angles, so we can mark them here. All right angles are congruent to each other, so that's the same as saying that angle E and angle R are congruent, but with a little bit more information. TE congruent to HR, EX congruent to RF. So I have side, angle, side, and that tells me that T next to side 1, H is next to side 1, X next to side 2, it's F, and then E was our right angle with R. Number 5, KN is parallel to KN is parallel to LM. And so I'm going to write my Z. That gives me alternate interior angles, NKM and LM, LMK, alternate interior angle theorem. Okay, so I have angle, I have a side here. I can say KM is congruent to itself by reflexive. I need another side or another angle. It either has to be these angles, which I don't know, or it has to be these sides, which I don't know. I know they're parallel, I don't know if they're congruent. And so we have not enough information. Okay, let's look at the next example. In this example, it's a what-if scenario. So if we have two diagrams, can we say that these two triangles are congruent? Well, I have angle, angle, side. That's not one of the congruence statements that I've seen before, right? Angle, angle, side. However, the congruent statements I have say I can have side, 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 but I can't get that these sides are congruent. I can have side, angle, side, which would mean I need this side to be congruent. Still, I don't have enough information for that. Or I need angle side angle, which means that I would need angle A and D to be congruent. That we can do. So this is not a table discussion, unfortunately. What we can do is we can say angle A is congruent to angle D by the third angle theorem. And so we can use angle side angle. But that will always be the case. Every time we have angle, angle side, we can always find that third angle. And therefore, we have a new congruence theorem, which is that every time we have angle, angle side, because that implies that third angle, it also gives us a congruence. Angle, angle, side. Okay, so let's look at some examples. Here we have angle, side, angle, side, angle, side, yes. And this one we have angle, side. We can always use the reflexive properties, but SSA does not work. Not enough information. And then we have here side, vertical angles, side. So we use vertical angles, and then we use SAS, yes. Okay, what I'd like you to do is fill in, pause the video, in your own words, the 4 congruence theorems that we have. For our last section, we're proving that triangles are congruent. So our goal or our objective, even though I didn't type it on this paper, is to be able to use those 4 congruence theorems in order to say when 2 triangles are congruent. So our first theorem that we looked at, or our first postulate, was SSS. So we need, in a proof, if we're using SSS, we need to say that 3 sides are congruent. So in this diagram, we have AB congruent to RS, BC, that's 2 hash marks, ST, and CA is RT. Now, for these congruent statements, RS, SR, that's okay. For the triangle congruence statement, this is where it absolutely has to be in order. And so we say A is between 1 and 3, R is between 1 and 3. Angle A matches with angle R. B between 1 and 2, S is between 1 and 2. C goes with T. Okay. Our second postulate, SAS, we need 2 sides, and important, it has to be the angle between them. It has to be the angle between them. And so we have SR with VU, angle R with angle U, RT with UW, and here's where we have to be careful. Triangle SRT, S is with the 2, V, R is congruent to U, and our last letter is W. And then our third postulate, which is angle side angle, which really is also the angle angle side. As long as we have 2 angles, we know we have the third. So as long as you can do 2 angles and any side, we can use this theorem. So we say angle A is with angle D, AC with DF, angle C with angle F, and then A is congruent to D, B is unmarked, goes with E, C goes with F. Let's apply it. A couple proofs. So we are given that TU is congruent to VW. You have to mark this on your diagram. For the test, there will be points awarded for the diagram. So if you do not have a diagram, you will lose those points. So here we have TU congruent with VW, angle UTV and WVT are right angles. So I can put the little right angle mark. What we want to show is that the triangles are congruent. That tells me my last statement should be exactly this. Triangle TUV congruent to triangle VWT. Okay, I don't know how we're going to get there yet, but I know that has to be the last statement. So we have our first statement is what was given. Our second statement, how do we know that these two angles, UTV and WVT, are congruent? All right angles are congruent. 90 equals 90. No matter where the angle is, a 90-degree angle will be congruent to any other 90-degree angle. Okay, so we have a side, we have an angle, we need a side or another angle. Here, I can see we have a side, and that is going to be the reflexive property, which is stated here. So we say TV is congruent to TV. That gives us our side. SAS is our congruence postulate. In our next proof, we want to start with what was given. So PQ bisects SPT. Segment PQ bisects angle SPT. Also, segment SP is congruent to TP. Okay, so on my diagram, I can mark PQ, SPT. There's my two angles. We also know SP and PT. So my next statement should be those congruencies that I just marked. Angle SPQ is congruent to angle TPQ. By the definition of angle, and it's important, you have to write the word angle bisector, because this is not a segment bisector. Okay, so I have here a segment, I have an angle, I need an angle or a segment. Well, here I have PQ, nice and reflexive for us. So PQ is congruent to PQ. Reflexive property. And that gives me a side, so my congruent statement will be SAS. Okay, in our next proof, we are given FJ congruent to HJ. Make sure you're putting that they're segments, and that is given. And then mark it on the diagram. FJ and HJ are congruent. We also know that G is the midpoint of FH. So what does that tell us? Well, that tells us that two marks, FG is congruent to GH by definition of midpoint. I have side, I need an angle or a third side. We have here the reflexive property to give us GJ congruent to GJ by reflexive. So that tells me side, side, side. Make sure your final statement matches what we've been asked to prove. So this should say triangle FGJ is congruent to triangle HGJ by SSS. Okay, we're almost there. 3 more proofs. On our last page, number 4, start with what's given. LM is congruent to NP, and LP is congruent to NM. Mark it on the diagram. It's already marked there. What do we need? Well, we need an angle or a third side, and we have here a third side by reflexive, Ln with Ln, which gives us, match your congruent statement, triangle LMN congruent to triangle NPL by SSS. Nice and straightforward. Our next one, we have MT bisects an angle. That makes it an angle bisector. We have two right angles. So let's write here, MT bisects angle AMH. So that means my next statement should say those are congruent. Angle AMT, angle HMT, by the definition of angle bisector. And then we said ATM and HTM are right angles. So we can also say that those two angles are congruent. ATM and HTM, all right angles are congruent. Okay, so we have angle, angle. What theorem can we use? We need a side. Always, always, we will need at least one side. And so we can use our reflexive again. And that will say that TM is congruent to TM. So we have two angles and the side between them. That's angle, side, angle. 5:30 angle, side, angle. It's not about what order it's written in the proof. It's about the order they are in the diagram. And so we have triangle MAT congruent to triangle MHT. Okay, our last proof for this video, given OR is congruent to MD and OR is parallel to DM. Immediately I'm going to draw my Z. We want to prove these two triangles are congruent. So we have our given. What else do we know? Well, the reason I draw my Z is so that we can have our alternate interior angles congruent. So that's ROM congruent to DMO. That's by alternate interior angle theorem. Okay, so we have a side, we have an angle. We need either the angle that goes on the other side of the side, or we need the side that's on the other side of the angle. We have here the reflexive property, OM with OM, which says now we have side, angle, side. Side, angle, side. To give me triangles, copy it directly. DOM and RMO. Okay. Make sure that you understand how to write these proofs, and I'll see you at 11 o'clock.